Hello everyone, my name is Shrish and today I will be experimenting on electromagnetism and comparing it with conventional magnets. But before that, let us talk about the basics. A compass mainly comprises of a compass needle which is a magnet by itself. It detects the Earth's natural magnetic field and points to the north and south poles respectively. However, when we bring a permanent neodymium magnet close to the compass, you will notice a deflection. This is because the magnetic field exerted by the magnet is stronger than the Earth's natural magnetic field, and thus we can observe an interference which results in a deflection of the compass needle in favor of the neodymium magnet. Unlike poles attract, and as such, we can observe that when the north pole of the magnet approaches the compass needle, the needle deflects to south, and when the south pole approaches the needle deflects north. Well, that explains that. What if we now replace the neodymium magnet with an electromagnet? But first, what is an electromagnet? An electromagnet is a sort of circuit which allows a magnetic material, which can be steel, iron, nickel or cobalt, to behave like a magnet when a current passes through it. This is the basic setup of an electromagnet. It comprises of a battery to provide the current and a paperclip made of steel to act as a magnetic object and wires to coil around the magnetic object and connect it to the battery. When we flip the on switch of the battery, this should behave like a magnet. Let us test this out by repeating the same experiment above, but this time with an electromagnet. If you notice, a similar deflection in the compass was observed when the electromagnet is used in place of a conventional neodymium magnet. So our electromagnet works and is behaving like a magnet. We can also deduce the polarity of our electromagnet by observing whether our needle deflects south or north when a pole of the paperclip is brought towards the compass. However, you may also notice that the deflection of the compass needle is not as strong as when the neodymium magnet was used. This might be because of the limited strength of our electromagnet. So, how can we increase the strength of our electromagnet? We can use a bigger magnetic object in this case and have a greater number of coils around the object. Moreover, we can increase the voltage of our battery such that more current is passing through the magnetic object. Well, that concludes my little experiment here. Thank you.